Hello, I am Heechan from Math B Block, and today I'm going to talk about the laws of exponents. Please note that I'm going to talk about one law only. So for level 1 and 2, we were required to make a table, and the table had to contain exponents of 2, which would be shown in 3 different forms: the exponent form, or the index form, standard form, and expanded form. Although the requirements were only from 2 to the power of 4 to 2 to the power of negative 4, I put 2 to the power of 5 and 2 to the power of 6 on the table for a reason I'll talk about later. So for level 3 and 4, this was my conjecture of b to the power of n multiplied by b to the power of m equals b to the power of n plus m. Also, this is my table for level 3 to 4, which the exponents are 3. I also put 3 to the power of 5 and 3 to the power of 6 as an extra, which would be like the table in levels 1 and 2. For level 5 and 6, we have to describe the relationship between x to the power of n and x to the power of negative n, which we were actually supposed to describe the relationship between 2 to the power of 4 and 2 to the power of negative 4, 2 to the power of 3 and 2 to the power of negative 3, and so on until 2 to the power of 1 and 2 to the power of negative 1. So, this also proves that x to the power of 0 is 1, since 0 does not have an opposing number, so it will equal to 1 as well. And the conjecture of x to the power of 0 is 1 proves that the conjecture that states x to the power of n multiplied by x to the power of negative n equals 1. Level 7 to 8. So now we need to go in depth of the conjecture of b to the power of n multiplied by b to the power of m is b to the power of n plus m. So to prove this conjecture, we need to look at other laws or conjectures, which there are 4 other laws. So all of the 5 laws are product law, quotient law, power of a power law, dividing law, and multiplication law, which I chose multiplication law. So since multiplying has a strong connection with division, since it is just like the opposite, so I'll use the dividing law, which is going to be fairly easy to understand. The dividing law is b to the power of n divided by b to the power of m equals b to the power of n minus m, so which is just like similar to the multiplication law, but uses subtractions and like division, which is just like the opposite of the multiplication law. And since this dividing law works, it just is the opposite of the multiplication law. And if we put the numbers in, for an example, then 3 to the power of 4 divided by 3 to the power of 2 equals 3 to the power of 4 minus 2, which is 81 divided by 9 equals 3 to the power of 2, which equals 9. And this proves that the division law is correct. So to prove this law, once again, 2 to the power of 2 multiplied by 2 to the power of 4 equals 2 times 2 times 2 times 2 times 2 times 2 equals 64, which equals 2 times 2 plus 4 equals 2 times 6, which is also 64. So therefore, 2 to the power of 2 times 2 to the power of 4 equals 2 times 2 times 2 times 2 times 2 times 2 equals 2 to the power of 2 plus 4 equals 64. So these both equal 64. So this is true because the times sign changes to plus when the times sign changes to exponents, which means the exponents is like bigger than like exponents are bigger than like multiplication signs. So it increases like equally from addition to multiplication and to exponents or indices. So when multiplication changed to indices, the multiplication sign has to change to addition, which one goes down, then another goes up to match it. Like, if we think of it simply, 9 plus 1 is 10, and 9 minus 1 plus 1 plus 1, since 9 it was minus by 1, so 1 has to be added by 1 as well. And that equals to 10, which is the same as 9 plus 1. And notice how 1 goes down and 1 goes up. And this is just the same goes for this law, so it is kind of simple. So, thank you for watching.